Okay, simplifying I problems. In this first set of problems, all we have is I to an exponent. What we need to know about I is that the square root of -1 equals I. So if you squared both of these, we know that -1 equals I squared, and we're going to use that fundamental idea to help us simplify these problems. So what we're going to do is use the idea of law of exponents, that if you take a base to a power, then you multiply the exponents. And since I squared equals -1, I want to write all of our problems as an I squared. And so to do that, if your exponent is even to begin with, divide it by 2, and that'll give you your new exponent. So 4 divided by 2 is 2, and so I can write I squared, or I to the fourth is I squared to the second power. And because I squared is -1, we have -1 squared, which is a +1. All right, I to the fifth. If you have an odd exponent to begin with, you want to write it as an even exponent times an I. So we can subtract 1 from 5 and get I to the fourth. And because of laws of exponents again, the product property tells us that if we multiply two bases, we add their exponents. So I to the fourth times I is still equivalent to I to the fifth. And like the previous example, I to the fourth can be written as I squared to the 2, and we have to multiply times I. I squared to the 2 is -1, I'm sorry, a +1, and 1 times I equals I. And so from these two examples, we can state that I to an even exponent is going to give us a 1 or a -1, and I to an odd exponent is going to give us an I or a -I, and that's all going to depend on if we have an even number of I's after we take 1 away from our odd exponent. So this next one, see I to the 30, I can go ahead and say that it's going to be 1 or -1, and then all it will depend on is how many I squareds are here. 30 divided by 2 is 15, so we have I squared to the 15th, and 15 is an odd number. All right, so if we have I squared, which is -1 to the 15, anytime you have a negative number to an odd exponent, you're going to get a negative number. So a negative number to an odd exponent, negative number. So this is going to stay -1. All right. So our next problem is I to the 45. 45 is odd, so we're going to write that as I to the 44 times I. We just subtract 1 from the 45 to get 44. I to the 44 is even, so we know it's a 1 or a -1, and that's going to depend on if 44 divided by 2 is odd or even. And I squared, or 44 divided by 2, will be 22. So I squared to the 22 times I squared becomes -1. -1 to the 22, it's an even number of times, so it's a +1 times I, which gives us a positive I. And so if you have I squared to an even, you know that it's a +1, and I squared to an odd is a -1.
Sorry, there was a problem. Please try again.
Thank you, Google. All right, so let's look at this next set of problems. Treat these i's like x's until the end. So 3i times 5i is 15i squared, and what is I squared? It's -1. So this is like 15 times -1, and so we get a -15. In our second problem, we're going to square the 2i, and we get 4i squared times 6i. I would suggest going ahead and simplifying this I squared to a -1. So it gives us 4 times -1 times 6i. And so 4 times -1 is -4 times 6i, and we get a -24i as our solution. In the third example here, I would go ahead and simplify your I squared, and so we get negative 4 times negative 1 squared, which gives us 4 squared, which is 16. All right. In our last two examples here, we need to use what is called the complex conjugate. And so the idea comes from, if you have a plus bi and you multiply a plus bi, a complex number, this is our real number, this is our imaginary. So a real number and an imaginary number give us a complex number. So this whole piece is complex. And we're going to use the complex conjugate, which would be a minus bi. And when you multiply by the conjugate, you will get a real number. And if we FOIL this out, a times a, we get a squared. And a times negative bi is negative abi. And bi times a is a positive abi. And bi times negative bi is a negative bi squared. All right, so what we see here is that your negative abi and your positive abi cancel, leaving us with a squared minus bi squared. And in this bi squared, we're going to have to square both terms into parentheses, so we get a squared minus b squared I squared. And we know I squared to be negative 1, so this is a squared minus b squared to the negative 1, which would give us a squared plus b squared. And so both of these terms here are real. This term up here was imaginary only because of the I, and so now that it's just b was acting as our coefficient of the imaginary number. And so here we see that we now have a real solution. And so we're going to use this idea over here on this first problem. We cannot have a imaginary number in the denominator. So to get rid of the denominator or make the denominator real, we need to multiply by its conjugate, which is 2 plus I. All right, and so the only way you can multiply a number by another number and not have anything change is to multiply by 1. And since we have 2 plus I over 2 plus I, it's still equivalent to 1. So although it will affect the look of the number, it is still equivalent. All right, so we multiply, and we're going to FOIL here across. And so across the top, we get 5 times 2, which is 10, and 5 times I, which is a positive 5I. And then we have I times 2, which is a positive 2I, and I times I, which is a positive I squared. And then on the bottom, we have 2 times 2, which is 4, and then 2 times I, which is positive 2I. And then you have a negative I times 2, which is a negative 2I, and negative I times negative I is a negative I squared. And so what we see here on the top, this simplifies to 10 plus 7I plus a negative 1, because I squared is negative 1. And on the bottom, the 2I and negative 2I cancel, leaving us with 4 minus a negative 1. So to simplify this all the way, we have this negative 1 and 10 becomes 9 plus 7I. And on the bottom, 4 minus a negative 1 becomes 5. All right. In our next example, we have 3 over negative 3I, or sorry, 2 over negative 3I. And so we want to multiply this by positive 3I over positive 3I. And so that would be the conjugate of our denominator. And so we're going to multiply straight across, and we get 6I over negative 9 I squared. And negative 9I squared, the I squared becomes a negative 1. So 6I over negative 9 times negative 1, which gives us 6I over 9, which can reduce to 2 2i over 3. And so we do need to reduce the fraction into lowest terms. And so this would be our solution for simplifying the conjugate. All right, guys, I hope this video helps.